All right, this is the solution for topic question number 1 from the 1.3 topic question set. I presume you have your the topic question in front of you so you could read the problem again. All right, so in this problem we've got two vehicles, two cars. Car A accelerates from rest, constant acceleration AA, and goes a distance XA. We can set the initial position to 0, so even though XA from a literal standpoint means a position, a final position, it's actually the displacement because we started at 0. And after traveling that far and accelerating by that amount, it's moving at a velocity VA. Same for car B. Let me adjust this so it's a little bit easier to see there we go. So car B, right, same idea, but car B accelerates at a different acceleration, maybe, and gets to 2 VA after traveling twice as far. Also where the initial position is 0, so we could treat this as, even though technically it's a position, we're going to treat it as a displacement or a distance traveled. Okay, so what are we trying to find? We're trying to find AB. And if you look at the multiple choice questions, they imply something more specific. They want AB in terms of AA. Okay, so how do we solve a problem like this? Well, we use our kinematics models, our 3 equations, and we've got velocities. Some are known, right, 0. Some are not known. We just know how they relate. One is twice the other. We're treating AA almost as if it was a known, right, because we want AB in terms of AA. So we don't have to solve for it. We're not trying to find AA to say AA equals stuff. We're trying to find AB. So AB is kind of an unknown. We know how far B travels in terms of how A travels. So if we look at our equations, the first equation has time in it. And I'll just jot those down real fast, but I'll probably erase them right away, right? So we have V equals V naught plus AT. We also have X equals X naught plus V naught T plus 1/2 AT squared. Commentary on the actual equations. If you look on the equation sheet, you've got Vx and Vx naught. So the x's that I didn't write here just mean that it's the velocity in the same dimension as this equation. That's all that means. Okay, and then we have one more. V squared equals V naught squared plus 2a delta x. Okay, so part of using those equations is not just relying on the letters appearing. You got to know what they mean, right? So this is a displacement. Well, if we started at 0, then our final position is the same as that. So that's one thing you got to make sure it doesn't throw you off. You can't just go, oh, what if the letters aren't the same, I can't use them. You have to know what the letters mean so that you could use the symbols that might be specific to a certain problem. Okay, which of these equations might help? Well, the problem with these two is that they have t in it. We have no t information here. Could we derive it? Could we represent it? Maybe. Sometimes we'll may run into a problem where we have to. But why not use or pick an equation that seems to use only what's been presented or you're given? And that's this third guy. So I'm going to rewrite that as we solve this. So we have this equation. V squared equals V naught squared plus 2a delta x. Good habit, always write the equation in its most general format, in other words, the one off the equation sheet. Now I'm going to customize it for this problem. Well, this means if I look at A, that velocity V, final velocity in this system, corresponds to VA. So VA squared is equal to VA naught squared plus 2a delta, this is AA, right? And this delta x is now XA. So we've gone from general equation, customize it to the particular problem. Okay, well, I want AB in terms of AA. Well, I only have AA here, right? So I'll write VB. I'll look at B now. I'll do the same thing. I'll go VB squared is equal to VB naught squared plus 2AB XB. But we can simplify some things. So this guy is actually 2VA. So this is 2VA squared. This is just 0, right? In fact, they're both 0. So these just go to 0. And I've got VB squared equals 0 plus 2AB, but XB is just 2XA. Okay. Let's just, I've got my AB there. So since I'm trying to find AB, I'm going to keep working with this one and just see where it takes me. So I'll just go ahead and do the square. 4VA squared has to equal 4. Or I'm going to, let's go 4, 2 times 2, 4, AB, XA. Now I want AB in terms of AA. It's not, may not be obvious to you yet that you have AA written out, because you've got, the only place I have AA right now in my work is up here. So let's see what happens if we play with this guy. If you do a little algebra, okay, this is a 0. So I get VA squared has to equal 2AA XA. All right, that's kind of interesting. I've got XA, VA. Looks like I've got AB and I've got AA. It should feel like we're getting closer. But I want AB in terms of AA. So what's AA? Maybe it'll help me to see what AA is if I just rearrange things so it's isolated. So I'm going to write AA out all by itself to help my brain recognize what AA looks like. Maybe that'll help. AA looks like VA squared all over 2XA. All right, do I have VA squareds? Oh, I've got VA squared here. I've got XA's here. So why don't I rearrange this one? So if I solve for AB, AB is going to equal 4 VA squared all over 4XA. Whoops, yeah, 4XA. I've got AA is just V squared over 2XA. So if I want AB in terms of AA, play with this so that it looks like AB equals something, a function of this whole thing. So this is where the physics is done. Okay. In fact, I would say we did the real physics know-how was picking the equation, realizing that you're just trying to find this, so you should have to isolate for that guy. But really, the physics is done almost when you pick which equation to use. The rest is mostly math skills, right? And seeing what pattern to try and what pattern stands out that gets you to this, gets you to see what that is. AB in terms of AA. So one technique is, especially with these kinds of questions, help your brain see patterns by isolating, getting expression for one, getting expression for the other, an actual thing equals stuff. But this part, there's no technique here. This is just, do you see do you see this thing in here? And the short answer is yeah, right? So if I put VA squared over 2XA, so what will get me this? Well, if I need to multiply this thing by what? 4? I need to multiply the top by 4. That'll give me that. If I multiply the bottom by 2, it'll give me that. Right? So this is AA, and 4 over 2 is just 2. So 2A over A. And that is number 1.